Okay, I think we can, in that case, just jump over to Breakout 2, and Gavin, our facilitator, is going to provide the report out for us.
Just doing a quick sound check.
Gotcha.
All right, awesome. Let me just quickly, okay, share the screen. There'll be a lot. I'm hoping you can see the notes on the screen. Yeah, I might zoom in a little bit just to make it easier. Okay, so with the Breakout 2 session, the main focus was trying to think of ideal instrumentation deployment style versus mission architecture, mainly looking at the differences between a sortie and a base camp. And we weren't able to cover all the questions in details, but we mainly got to focus on the first two guiding questions of should astronauts focus on traditional field geology or making in situ measurements, and what types of measurements should be done in situ versus and also what equipment is required. And like Jose, I did highlight some important parts that did stand out during this discussion. But I think the first part that we discussed was trying to figure out the difference between short distance walking away from a base station versus longer range EVAs that might require the either option of a mobile instrument suite that doesn't need to be disassembled from a base camp, or if it does need to be disassembled, is that going to have an impact on maximizing EVA time? And I know one of the big consensus was that if we are going to have a lot more longer range EVAs trying to collect as much in situ and sampling as possible, we would probably want to ensure there is a separate mobile instrumentation suite or package that is probably similar to what is available at the base station, but is better, that can easily be moved by the astronauts during EVAs and put onto lunar roving vehicles that could also be taken back to base camp if required. And because then in that case, it would also remove, it also got brought through the discussion of if we do have a mobile instrumentation suite, what limitations from those instruments will we have to consider for the astronauts using EVAs? Will some of the instruments require longer setups, or do they require multiple components in order to operate? Because that's also going to impact the maximizing the amount of analysis and samples we can bring back. And this slowly led into more discussions on the combination of maximizing the time for humans, astronauts to actually collect data versus what robotic platforms can probably do in place of humans. There was the thought of if we're going to be if we want to maximize collecting samples to get high-grade science, should we then just have humans focus on collecting samples and collecting observations that we know that they can use intuition and human error to collect that robotic platforms can't, and rely robotic assets and platforms mainly to collect in situ analysis across the entire landing sites and traverse sites, and focus more on collecting imagery and panoramics around the area that could take up more time if a humans had to do that in addition to sampling. And that way it would actually maximize the amount of information we can get per site. And it will also be very useful, which leads into this next point that came up, if we wanted to have robotic platforms visit locations that we've sent human crews to already that have collected samples, and we continue to send rovers to consistently collect more geochemical and geophysical in situ measurements and collect new images if we were to return later on. This way, we know we can still continue to collect information from sites we know that human crewed missions won't be returning to, allowing us to maximize the science output and to also continue to provide more context for samples that the crewed missions would have collected. And this slowly moved into the second question, where we started to focus more onto the geophysics and geophysical experiments. If humans were prioritized to set up these experiments in the South Polar region, one disadvantage is we won't have global coverage because we'll be limited to where those crewed missions can go, versus robotics, which can be launched to multiple locations and get a much more global coverage of the moon. The major advantage of having humans, though, is that they can diagnose problems that the instrumentations and experiments might experience in real time, versus having to troubleshoot robotic software to actually try and fix the problem. And that's only assuming it could fix the problem, and then you run the risk that if the robotic software can't, then we run the rest of the experiment will be deemed a unsuccess. But with humans, we could be able to diagnose problems a lot more efficiently and be able to see what the actual problem is within real time. And then it also this moved on to a discussion of, should we have a mixture of both self-deployed and human-assisted instrument packages to best maximize the science input and ensure crews actually have more time to conduct experiments, such as sampling and doing detailed observations of outcrops that robotic platforms either take too long to complete or struggle to be able to discriminate certain rock types because they still yet can't automatically identify one rock type from another successfully. And this coming close to what we were discussing, we started to move a bit more into automated robotic platforms, whether or not we could acquire data quickly and consistently in some scenarios using certain geophysical packages, and while we would use human astronauts to use intuition and common sense to deduce problems and acquire data that robotic platforms physically cannot collect, such as going over terrain that a rover could struggle in, but a human astronaut could potentially still traverse, or again, going back to discriminating lithologies that a rover camera probably can't do just quite yet, but a human will be able to tell two different rock types apart, or even two different textures apart from each other. And then near the end, we actually started to move more towards one new question, which was trying to find the best places to sample volatiles and what instrumentation suites and procedures would be the best. Illumination condition definitely came up, trying to figure out the best way to get around it. How can we identify lithologies and potentially volatile-rich areas in these areas? And we know that EVA suits are going to struggle to be able to withstand the temperature conditions, so we needed to find the best ways to study volatiles, which came back to probably producing coring instruments that can go definitely below 1 meter beneath the surface. And then it started to come into our final discussion question, which was how much coring versus how much rock sampling is actually required to get the most out of each sortie mission. And there was discussion of sampling can be done a lot easier and requires less setup and logistics than a drilling operation, but then it was brought during the session today that being able to drill a few meters, even several beneath the surface, can provide sometimes a lot more information, especially on volatiles and maybe collecting a sample on the surface that has probably been exposed to cosmic and solar radiation or has been bombarded and impacted and alterated by impact events for millions, if not billions of years. And I think that's essentially what we ended on through our discussion. So if there's anything, Tim, that I've missed, or again, anyone from the breakout room where if I might have said something incorrectly or misinterpreted something, please feel free to speak out.
I think you did a fantastic job, Gavin. Thank you. I think the only thing I'll note is, kind of right at the very end, we had a little bit more of an extended discussion about drilling and the importance of coring and drilling and stable platform to do that. And it's going to be really important, especially for volatile sampling. I think there was just kind of an emphasis on the need for that particular type of sampling, right towards the end of our discussion. Well, other than that, you did a great job summarizing. So with that, I think we're done. This was a fantastic day. I really want to again thank all of our speakers who did a great job presenting different aspects of crewed operations and scientific instrumentation that we'll need to think about, as well as traditional field geology. We had some great discussions in the breakout sessions. And please look out for the report that we'll be working on based off of the discussions that we've had today. So I think I'm done. Jose, anything else you want to add?
I just want to thank everybody for participating today. I want to especially thank Gavin and Tara for being great facilitators and helping with running the sessions. And yeah, we will be in touch with our report at some point in the near future. So stay tuned for that.
And yeah, one last thing. Thank you very much to Ricky Guest for helping us all out with our connectivity. And thank you to the headquarters and Surrey folks for running the slides today as well. All right, take care, everyone. I'll see at least some of you soon. Bye.